explain the HDL code for the task 9.3D. So first of all, I am going to explain the diagram that is given in the task sheet as well as the notes of the classroom. So first of all, here CPU consists of several logic gates such as the ALU, A register, D register, program counter and the multiplexer. So the CPU here, that is the connection between the computer and the computer programmer. It specifies the chip name and the input and the output pins, function of the CPU and additional compounds. So the diagram consists of the input and output pins. So the input pins are the instructions IN, M and the reset, and the outlet pins are the out M, write M, address M and PC. So here ALU gives the output M. So ALU must specify some new things that the CPU, like the CPU is going to drive in the data memory. Also the ALU do the write operation in the data memory also. It allows the CPU to write the content in the data memory and the write memory. Here, as we have learned in the week 5, the program counter holds the next instruction, decodes and executes instruction. So I am going to explain the code. So here we have the contents that specify the CPU interface, input and output pins. Since we are implementing, so first part is the header section. So we are implementing, and the input and the pins consist of the 16-bit of the memory that is in M and the 16-bit of the instruction that is used for the execution of the code, and the rest add signals whether to restart the program. Also it consists of the output pins, and here there is an out M and write M, address M and program counter 15-bit. So PC here executes the next instruction of the RAM address, and the address M is the RAM address and the write M is what we have to write in the M, and the out M is the M value output, that is memory for the output. So now we are going to start with the previous section. So we have 3 gates, not and mux 16. So CPU uses this for the specific operation, these gates, and there are the 2 types of instruction in the instruction memory. AC, that is the A instruction, and the C instruction. A instruction symbolizes syntax as @value. So as we have already studied in the previous notes and lectures, and the C instruction has the symbol syntax that is equal to come. Now I am going to explain my code. So here is this code. Not get is used to tell the instruction is coming, that is a instruction. CPU decodes the 16-bit value instruction into the OP code and the 15-bit value. If the OP code is 0, the instruction is for instance, and the instruction coming in the CPU A instruction. CPU take 15-bit value and stores value in the A register. So also in the diagram we can see that A register can be fed by instruction or the ALU output. The ALU output is fed UB register, and also we use the AND gate for the C instruction. The mux is also used to select if the instruction or ALU output is stored into the A register if the load bit is 1. Either the instruction or ALU output is fed here. On the other hand, if the A register is used to store the value that is fed in the A register, it takes in the output of the A register in the form of the mux, and the out A from the A out generates the value that is currently stored in the register. Next is the mux 16, which takes the output of the A register and the value stored currently in the data memory in the M. Either A or M will be fed into the ALU depending on the top bit instruction value. The AND gate in the next is determined ALU output that is loaded to the D register, and the D register is then implemented to load and store the value of D register from the ALU. ALU computes the function in two inputs. In this case, it would be stored in the D register or the value of A, and then next D and M register, and then generates the output. If consists of input, it consists of input control bits such as ZX, NX, NY, ZY, F, no, which are indicators of the function that is take it on the two inputs to produce outputs. The control bits such as ZR and NG determines the properties of the result. The following code, which consists of 2 or 16 and gates, computes the output successfully right on the data memory that refers to the 16 code line. It also determines address of write, and the 1 determines the content in the data memory, and in the last AND gate allows the CPU to write the content to the data memory. In the last, the program counter, as I have already explained, is the register which consists the address of the function to be executed. Next, the load bit of the PC is determined by the jump bits and the ALU outputs. So this part of the code determines the jump instruction and checked the ALU output to see if the conditions are met. If it is the instruction and the code and the conditions are met, then the PC is loaded. Then it will allow the CPU to jump to specific value of symbol. If not loaded, the PC is incremented. Incrementation here means the CPU needs the reset instructions. Thank you.